Hello, ladies and gentlemen. This is Mr. Schaefer, and we are flipping this variables and patterns 1.3, converting data to a graph. Now, this is something that you've done already back in 1.2, but we're using different data, and this time we're going to analyze it and get a really good grasp on the largest amount of distance where the group traveled, things like that. So, our I can statement, I can analyze and display data on a graph. Let me change that. I can analyze and display data on a graph. There we go. All ready? Moving on. All right, let's transfer the data from this chart to the coordinate graph. Right now, I want you to pause the video. I want you to pick out your scale. I want you to label that graph for what scale you're going to have for your x-axis and your y-axis. And then I want you to start placing that on. When you unpause it, I'll have my data already up there. Again, time almost always goes on the x-axis. All right, just to make sure that you did it correct. First of all, the x-axis went up by 0.5s. The time went up every half hour, or 0.5 of an hour. And then the y-axis, I figured out that I can go up by 5s. Now, 45 isn't exactly at the top, and that's fine. That's okay. But if I went up by 10s, I wouldn't have been, 45 would have been right about here, and that wouldn't have filled up at least half the graph. That's your goal, to fill up at least half of each axis. And if I went up by 1s or 2s, then 45 wouldn't have even been on there. So 5 was the exact choice that you want to make. And this is what my data looks like. I am going to connect these points now because there is actually information on the time side. Let me label these axes quick. Make sure that you do that as well. And there is information in between each half hour and each hour, everything like that. So I am going to connect the lines now just to get a better view and be able to actually figure out what I was doing at 2¼ hours or 3 hours and 15 minutes. Please make sure to connect your dots as well because that will be important for us to answer some of these questions. Let's look at some of these questions. Analyze your graph by answering the following questions. Give the coordinate pair for the third point in your graph. What information does this point give you? Well, if we go back, the third point was right here. It was 1, 2, 3. And that was 1 and 15. We can also get that information right here, 1 and 15. So we're going to write it like this. So my coordinate pair is going to be 1, 15. Make sure to write that down. And what information does this point give us? Well, it says that in 1 hour, they rode 15 miles. All right, next one. Connecting points on a graph sometimes helps you see a pattern more clearly. You can connect the points to consider what is happening on the intervals. Connect the points in your graph with the straight line segments. We did this already. But use the line segments to estimate the distance traveled at 3/4 of an hour, or 0.75. So if I was looking for 0.75, 0, 0.5, 0.75 is going to be right in between here, 0.5 and 1. So let's travel up that line, see where we'd be at, and we'd be at right here. And I'd say that's about 12 or 13 miles that they would have traveled in 3/4 of an hour, or 45 minutes. Make sure to write that at the end of 2. All right, Sydney wants to describe day 1 of her tour. Using information from the table or graph, what can she write about the day's travel? How far did the group travel? If we go back, we can easily see that on our graph. Group traveled 45 miles. How much time did it take them? Again, easy to find on our chart and on our graph. Took them 5 hours. So let's write that in, 45 miles, and it took them 5 hours. And during which time intervals did they go the greatest distance? And which time intervals did they go the least distance? All right, so we're looking for the lines that jump the greatest or are inclined the most. Otherwise, we can come over here and we can actually find out the difference between each one. I'm going to do both. I'm going to guess which one looks the sharpest degree or has the most incline here. And then I'm going to actually figure out the correct answer over here. These two areas that I highlighted in blue, that I made a blue arrow towards, those I think are the areas that the two intervals that they made the most progress in. So I'd say between 0 and 0.5, that would be one interval. And between 2.5 and 3, that would be another interval. Let me just check actually on the chart to see if that's correct. They actually would have been correct with 0 to 0.5. If you look over at the chart, the group traveled 8 miles in that one. But looking at which ones traveled, when did they travel the least distance, then we're looking for a flat bar. We're looking for no movement whatsoever up. So that right there looks like this plateau. So between 3.5 and 4.5, those intervals, that's where they traveled the least. Moving back to our other slide, we'll write that in. Where did they travel the greatest distance? What time intervals? 0 to 0.5. And which time intervals did they go the least distance? 3.5 to 4.5. All right, I wrote in my answers for that second bullet point in C. Now I'm going to look at this final bullet point. Did the riders go farther in the first half or the second half? Well, first half of the day, well, if you look at 0 to 5, halfway in between would be 2.5. So at 2.5, they went 27 miles. After that, they went up to 45 miles. So here's the difference. I'm going to get rid of this. I'm going to get rid of this. And I'm going to break it up in the half day. So in the first part of the day, they went 27 miles. In the second half of the day, they went 18 miles. So the first half of the day was definitely the time when they had the most distance traveled. Write that in for your last answer. Ask any additional questions. Have a great day.